So in today's screencast, we are going to talk about LiteLLM Hack. What happened and how it happened. That's what we're going to talk about. And if you enjoy crime thriller novels or movies, you may enjoy this screencast because here we're going to see how hackers' mind work and how they exploited their understanding of GitHub and Python packaging, etc. So let's start with what is LiteLLM. LiteLLM is a Python package. It's kind of a wrapper, you can think about it, or it's a router, as if you want to think about it, which can route your calls to different LLMs. Like hundreds of different LLMs can be called using LiteLLM package. And most of AI projects, people writing AI agents are using LiteLLM to call different LLM. If you're using LiteLLM, just with one line change, you can suddenly start calling your different LLM, which can be Anthropic or Gemini or ChatGPT or anything else. So that's a very important package. Hundreds and thousands and millions of people use this LiteLLM package. And what hackers have done, they poison this LiteLLM package. And whoever is using this LiteLLM, hackers are getting the keys and all the secrets of their project. This is hackers here. And if you're using LiteLLM, which is poisonous LLM, they can access your keys and secrets from environment file, from your memory space, and all those places. So how this LiteLLM got compromised? So to understand that, let's go back to another thing called Trivi. This is a security scanner package, which is used by a lot of projects to scan the security vulnerability in their CI/CD pipeline. It's an open source and written by a lot of people, like a lot of people contributing to the code, and it is trusted by many, many projects. And LiteLLM also uses Trivi in their CI/CD pipeline to check for any security issues. Okay. Now, Trivi is using a GitHub action called pull request target, right? And this was the issue. What this GitHub action was saying that take any code from anybody who's trying to submit a code to this open source project and run the test and then see if the test passes and all. Then they have other thing in the pipeline to the code will be merged or reviewed and all that. This mistake is exactly a mistake which even a small kid doesn't do, where we teach young kids that don't take a chocolate from a stranger. But Trivi was doing this. It's taking any code from anybody, take the code from hackers and run it. Now this pull request target, again, this Trivi is an open source project, so their GitHub was open and they were using this, and hacker knew, and they were scanning all the repos in the world for this pull request target, kind of open door. So they submitted a code here. Hacker submitted a code, which is a bad code, to Trivi to run, to accept their code and run it. So when they were running the code is actually taking the secret of Trivi and sending it back to the hackers. So what they send is, it's called PAT, Personal Access Token. This token means if you can act as one of the member of Trivi team, and you have all the right access and everything. So they had all the access of Trivi Git repo. And this thing is very dangerous if it leaks. And because they were running this test of taking from the public code, which ran this code and transferred them the PAT, the Trivi went ahead and maybe even changed this PAT. It's very difficult for a very, very big projects to just change these access tokens and all, because everything will break, the CI/CD pipeline will break, and a lot of people dependent on these things. Everything will be a big mess. So they changed what they did mistake. I think Trivi did. They changed the codes, a lot of keys and all those things, but the hackers still have the access. So they say they got rid of this pat because that was leaked and they changed it, but hackers still got the second pat, which was used by Trivi after the change. So they still have the right access to the Trivi. And then the next smart thing they have done is they wrote some code, hackers wrote the code, and put it not in a main branch, but created a branch, say orphan branch. This orphan branch is having their bad code, right, which is transferring all the keys and everything. And they spoofed it as if it's written by some Trivi member. Everything was same, and it was left in an orphan branch. So it was not in a main branch, so that nobody paid attention to it, so they couldn't catch it. The next thing they did after writing this orphan branch, they poisoned the Trivi tagging mechanism. So they changed the tags in GitHub and pointed it to their bad code, which is sitting in an orphan branch. So they changed the tags. Now, tags are nothing but it is pointing to a code, which code need to be pulled up when this tag is called. And LiteLLM now, they go ahead and call Trivi because Trivi is in their CI/CD pipeline. When they call this Trivi, they had tags pointing to Trivi, and this tag was pointing to bad code. So now LiteLLM is having the bad code which has transferred their publishing tokens to hackers. This publishing token is for Python libraries, Python packages, Python package index. So they got the publishing token of LiteLLM. And once they got the publishing token of this package LiteLLM, what hackers did, they released another LiteLLM package in Python package manager index with a bad code. And now this LiteLLM is downloaded by hundreds of people, thousands of people, and all their key secrets were given to hacker. But as we say, maybe the aliens are watching us to protect us or whatever, the universe works in a mysterious way. We would have been suffering a huge loss, but fortunately, the hackers write a wrong code. They made a mistake. They introduced a bug in their code, which, because of that, what happened is, as soon as this bad LiteLLM started running in people machine, it bombed. It literally bombed, and it's called fork bomb. And because of their mistake, as soon as you included this LiteLLM in your project and start running, it used to crash the machine, crash your Docker, wherever, because it's continuously fork the code. And this is a command in Unix where you can fork the command. Basically, this is used by DDoS, where they will take all the resources and machine will stop working. So that was a bug introduced by the hacker. We were very fortunate. And because that triggered a search, and then people find out that this LiteLLM, I guess the package was 182.7 and 182.8 was the package number, which was having the bad code. So they quickly found out and stopped LiteLLM from getting downloaded. Once that got blocked, then they went on and found out all this, what has happened. And we were very fortunate and lucky to have that bug, which is called fork bomb, which took down the system, and we caught what hackers were trying to do, and we saved ourselves. So fork bomb is so dangerous. Here's one code, interesting code I'll show you. This is a function which is called colon, and this is the function body where we call itself. The function colon is called, pipe it to itself, and all this run in the background, and then call this function. And this is a fork bomb function. So just this much text in a Unix bash shell can kill your machine. So anyway, I hope you understand what happened. Now I will add a article also with screencast so you can read it and see what exactly happened with LiteLLM. And there I will talk about in the article how you can protect yourself. One way is always use a particular release number and hash code of the package which you are using in your project, so you know exactly what you want. That create another problem that you will not have the latest all the time, but I think it's better to be safe than sorry. And make sure you just don't download random packages and all, because these hackers created a VS Code extension also after getting all the keys and everything. So if you're using that VS Code, you could be hurt also. And obviously, this was the most dangerous one because this is in everyone's CI/CD pipeline. This Trivy is, so it's much more harmful. So hope this gave you some clarity what happened in LiteLLM hack. And thanks for your time. See you next time. Bye.